Today, we're digging deep, and I mean really deep, into the story of a buried treasure. It's a substance that has literally fueled our modern world, but it holds a secret that's millions of years old. Let's get into it.
Just think about it for a second. What one thing that we pull out of the ground, runs our cars, powers our homes, and is even in the phone or computer you're using right now? It's not some shiny metal or precious gem.
The answer, it turns out, is this incredible inheritance. It's a gift from a world that doesn't even exist anymore, cooked deep inside the earth for a length of time that is, well, it's almost impossible to wrap your head around. And what we're talking about? Well, it's right there in the name: fossil fuels. They are quite literally fuels made from the fossilized remains of things that were alive a very, very, very long time ago.
So, how in the world did ancient plants and tiny sea creatures turn into the fuel we use today? Well, it's an absolutely epic story involving geology, chemistry, and just immense, unimaginable spans of time.
The scale of this whole process is just staggering. Okay, so picture this. About 300 million years ago, the Earth was covered in these dense, swampy forests and oceans just teeming with life. As all that life, plants, algae, plankton died, it got buried under layers and layers of mud and rock. And then, for millions of years, incredible pressure and heat did their thing, basically transforming all that dead stuff into super concentrated energy.
But it's not all one big recipe. There are two main versions. You've got coal, which is basically what's left of those gigantic ancient forests. And then you have petroleum, or oil, which mostly comes from tiny organisms that lived in the sea. When they died, they sank, got covered up, and slowly cooked over the eons.
For coal, the magic word is carbonization. As those dead plants get buried deeper and deeper, the intense pressure and heat literally squeeze out almost everything, the water, the other gases, until pretty much all that's left is carbon. And that gives us the hard, black, energy-packed rock we call coal.
All right, so we've got these raw materials, these hard black rocks, and this dark, gooey liquid. So what? How do we actually turn them into something useful? Well, that's the next chapter in this incredible story.
When you process coal, you unlock some seriously versatile stuff. You get coke, no, not the drink, and almost pure carbon that's absolutely essential for making steel. You get coal tar, this wild mixture that's the starting point for dyes, plastics, and get this, even perfumes. And of course, coal gas, a powerful fuel for industry.
But let's be honest, it's petroleum that really earns the nickname black gold. The value packed inside that dark, oily liquid is just off the charts, and for a very good reason.
The secret is a process called refining. See, the crude oil that comes out of the ground is a jumbled up mix of all sorts of different things. Refining is basically like unmixing it, carefully separating it out into all of its valuable parts, which are called fractions. And just look at what we get out of it. The list is just mind-blowing. We get LPG to cook our food, petrol and diesel for our cars and trucks, lubricating oils to keep engines running smoothly, paraffin wax for candles, and even Vaseline, and bitumen to pave our roads. It is truly woven into the fabric of our daily lives.
And believe it or not, it doesn't even stop there. We get these things called petrochemicals, which are the fundamental building blocks for a huge part of our modern world. We're talking detergents, synthetic fabrics like polyester, and yep, pretty much all the plastics you see around you.
Okay, so this stuff is amazing. It powers our lives, it builds our world. But, and you knew there was a but coming, there's a pretty big catch. This inheritance we got from the ancient Earth, well, it's not a bottomless pit.
Fossil fuels are what's known as an exhaustible resource. That's a fancy way of saying there's only so much of it in the ground. Unlike sunshine or wind, it doesn't get refilled. Once we use it all, it is gone. For good.
This source material has this really simple but brilliant way to think about it. Imagine a giant bowl of popcorn is being shared by 3 generations. The first generation is a small group, and they take a few handfuls. The second generation is much bigger, and they eat a whole lot more. By the time the third and largest generation shows up, the bowl is almost empty. And this leads to a pretty powerful and kind of uncomfortable question. Is it fair? Are the earlier generations being too greedy by using so much, knowing that the people who come after them will have less or maybe nothing at all? And the cost isn't just about the supply running out. The sources are very clear on this.
Burning these fuels is a major source of air pollution, and their use is also directly linked to global warming. So the big takeaway here is that using this ancient treasure, it comes with some serious consequences.
So this brings us to the final and maybe the most critical part of our whole story. What happens when it's gone? What does the future look like when this finite resource starts to run low? Because the clock is definitely ticking.
And this right here is the heart of the problem. It's an epic mismatch. Nature took millions of years to slowly create these fuels, and at the rate we're using them, our known reserves will only last for a few hundred years. The difference in those timescales is it's hard to even process.
And here's the really stark reality of it all. We can't just make more. We can't replicate those conditions, the crushing pressure, the intense heat, the millions of years, in some lab. Their creation was a one-time geological event. When they're gone, they're gone.
So let's just boil it all down. What's the ultimate takeaway? Fossil fuels are this incredible but absolutely finite gift from our planet's deep past. They built the world we live in, but using them has real, serious consequences. So the only logical path forward is that we have to be incredibly smart and careful, or judicious, about how we use whatever is left.
And that really leaves us with one final massive question to think about. We inherited this incredible treasure, this black gold from the past. But what energy legacy are we going to leave for the future? What kind of world will we pass on to the generations that come after us?